The deepest trenches of the ocean are vast, silent, and hostile territories of crushing pressure and eternal night. Yet it is here, in the darkest zone of the planet, that a mysterious, perfectly rounded sphere begins its effortless, mesmerizing flight. Forget the terrifying, toothy abyssal monsters of legend. This is the Dumbo Octopus, an ethereal, fascinating creature that challenges the limits of survival, wrapped in an undeniable, captivating, and utterly bizarre cuteness. Welcome back to Bizarre Creatures. Today, we dive into the abyssal secrets of this deep-sea marvel and explore the profound paradox of its softness, its stillness, and its perfect survival strategy. It earns its name from Disney's flying elephant, using two large, muscular, fluttering ears to glide gracefully and silently. A biological anomaly that appears to defy the very laws of hydrodynamics in the hostile darkness. Dumbo is more than just a biological oddity. It's an evolutionary champion that has perfected an incredibly low-energy lifestyle, a necessity for survival in the planet's most unforgiving, food-scarce, and physically demanding habitat. We are operating far beyond the reach of sunlight. In the Bathypelagic and Hadopelagic Zones, where the water pressure exceeds 400 times that of the surface, a force capable of instantly imploding most life forms. The Dumbo octopus belongs to the Grimpoteuthis genus, often called the umbrella octopus, because its 8 short, thick arms are seamlessly connected by a vast, gelatinous, and highly expressive webbing. Let's focus on its signature feature, those ears. They are not for hearing, but highly specialized, powerful muscular fins, complex propulsion units that beat with a rhythmic, mesmerizing, and energy-saving precision. Dumbo primarily relies on these fins to gain altitude, maintain its precise hover, and execute subtle course corrections, a method so remarkably energy efficient that it dictates the animal's entire slow-motion existence. Its 8 short arms, which are entirely linked by the extensive webbing, are primarily relegated to minor steering, or delicately resting on the soft, silty sea floor, rarely being used for active, power-intensive movement. Their core body composition is a biological triumph. Instead of dense bone or rigid cartilage, its entire structure is a soft, semi-gelatinous matrix designed to yield, not resist, the overwhelming forces. This jelly-like structure enables the creature to perfectly equalize the massive external pressure across its entire form, eliminating the huge metabolic cost required to maintain a rigid internal frame. Unlike surface dwellers, this is the core biological paradox of its defense. Dumbo is one of the very few octopus species that has completely lost its ink sac over countless generations of abyssal evolution. In this world of perpetual, absolute darkness, deploying an ink cloud serves absolutely no purpose. The creature is genetically forced to rely purely on its physical form and passive resilience against predation. That's why Dumbo employs only one definitive defensive tactic. It instantly pulls its flexible arms and webbing inward, folding the entire structure to form a featureless, soft, and extremely compact sphere. This passive, ball-like maneuver relies on physics and patience, making the creature an unappealing, slippery, and energy-wasting target that predators usually choose to ignore after a brief inspection. The Dumbo's large, widely spaced eyes, contributing so much to its unique charm, are not built for detailed vision, but are ultra-optimized solely for capturing maximum, fleeting light. They are specially adapted to detect the incredibly faint, ephemeral flashes of bioluminescence or living light produced by other organisms, which is their critical method of navigation and communication. This visual specialization allows Dumbo to recognize light patterns, but it limits their ability to perceive complex shapes or colors, seeing the world as ghostly trails of blue and green light. Another unique sensory specialization. Dumbo possesses tiny, delicate hair-like structures known as cilia, embedded along its ventral arms and across the connecting webbing. These microscopic cilia act as highly sensitive chemo and motion detectors, helping the Dumbo sense minute pressure waves, vibrations, and subtle chemical trails in the static deep water. This advanced sensory array allows the Dumbo to precisely map its immediate environment and pinpoint the exact location of scarce prey without ever needing to visually confirm their presence. Dumbo is the epitome of the patient, passive, and low-energy hunter, spending the vast majority of its life hovering silently near the seafloor, minimizing metabolic output. It never actively pursues prey. Instead, it relies entirely on serendipity, patiently waiting for the gentle currents to carry small worms, amphipods, and crustaceans directly into its waiting grasp. When prey is secured, Dumbo opens its small, specialized mouth and swallows the small organism whole, without any attempt to chew, tear, or process the food externally. This is a critical energy-saving practice because chewing would consume precious metabolic resources that are simply too difficult to replenish in the energy-poor abyssal zone. Their diet is simple yet vital, consisting of slow-moving, high-fat content scavengers that thrive only in the dark, silent trenches, ensuring Dumbo maximizes its caloric intake. Dumbo has a fascinating, energy-conservative, and highly adaptable reproductive cycle. They lay large, nutrient-dense eggs continuously and sporadically throughout the year. This strategy is a profound adaptation that eliminates the need for a fixed breeding season, allowing them to reproduce immediately when a high-value meal is secured or a partner is encountered. The female attaches these large, tough-shelled eggs to hard, stable, and often mineral-rich structures like deep-sea rocks or manganese nodules for long-term incubation. The young skip the vulnerable, free-floating larval stage entirely, hatching directly as fully formed, competent miniature adults ready for immediate, independent survival at the ocean floor. Dumbo is ultimate proof that successful evolution doesn't always favor powerful muscles, active defense, or aggression in the most extreme environments. Its entire survival is built upon sophisticated low-energy anatomy, extreme patience, and the perfect biological mastery of passive defense and soft-bodied strategies. The way Dumbo glides using its fins to fly is a beautiful, hypnotic reminder that profound biological wonder and grace can be found in the darkest, most unexpected places. Because of their extreme depth, Dumbo is historically safe from traditional surface fishing and commercial trawl nets, enjoying a rare form of immunity in the overexploited ocean world. However, the rapidly approaching and highly destructive industry of deep-sea mining poses a massive, direct, and immediate threat to the foundational bedrock of their habitat. Mining will physically obliterate the stable rocks and corals where Dumbo attaches its eggs, contaminating the entire silent, fragile ecosystem with toxic plumes of suspended sediment. Furthermore, global climate change, which alters deep ocean chemistry, temperature, and oxygen saturation, presents a long-term, unpredictable, and irreversible hazard to this fragile species. To protect this amazing creature, we must advocate fiercely for the international protection and study of the silent, complex, and vital deep-sea ecosystems before they are permanently destroyed. Subscribe to Bizarre Creatures and tell us, should we explore the sea otter, cutest, most violent, or the bizarre, otherworldly purple frog, weirdest, most elusive next?